Hi everyone, this is Ayush Aswal and I am making an explanation video of internal to test section B, where our first question is transforming raw variables into more informative ones is called feature engineering. What is feature engineering? Feature engineering is uh, uses domain knowledge to create features that help machine learning algorithm performs better. For a real world example, creating days until paydays from transaction date and salary schedule for credit risk models, or extracting day of week from time frames of sales prediction. Now second, our 12th question is predicting a numeric value such as salary is an example of regression. In regression we uh, predicts continuous numeric values, unlike classification with predict categories. Linear regression is the simplest form, but many sophisticated regression techniques exist. Now 13th question. Overfitting occurs when a model learns noise and specific details from training data instead of general patterns. The model becomes too complex and fails to generalize to new data. This is basically overfitting. So our fill in the blanks is a model that fit training data perfectly but fails on new data suffers from overfitting. Now our question 14 is dropout and weight penalties are example of dash method. So first we'll understand regularization techniques prevent overfitting by by constraining models complexity. Model method like include L1 L2 penalties and dropout in neural networks. It is regularization. Now question 15 is training multiple diverse model to improve accuracy is known as dash learning. It is ensemble. Ensemble method combines prediction from small multiple models using a wisdom of crowd approach. Examples include random forest bagging, boosting and stacking. Okay. Now our 16th question is a simple reference model for comparison is called a baseline model. Baseline models provide a reference point to measure improvement. They are typically simple heuristics or basic models that any sophisticated model should beat. Now our 17th question is independent unchanging data samples are described as independently identically distributed. Now the IIDs are independently identically data distributed. Assumption means each data point is independent and drawn from a same distribution. This is ideal but rarely perfect in real life. Many ML algorithms assume ID data. Now our 18th question is parameter tuned before training are called hyperparameters. These are the parameters that were trained before the model implementation. Like hyperparameters are the knobs you set before training data. That's said only. Now the common hyperparameters are learning rate, batch size, number of hidden layers, dropout rate, regularization parameter. Putting the weight into the data according to us, and comparing two versions statistically to see which performs better is A by B testing. Basically, A by B testing statically compares two approaches to determine which perform better and whether the difference is statistically significant. Like testing two ML models on the same held out data to see which has better accuracy, or comparing two website designs. Now, normalization typically rescales numeric features to the range of 0 to 1 or minus 1 to 1. Now 0 to 1, I think it's done by minmax, z-score, and minus 1 to 1 is done by what this method is decimal scaling. The difference between train and test performance measures model is generalization. Generalization measures how well a model performs on new unseen data compared to training data. Large gaps indicates overfitting. Where overfitting we have discussed earlier. Overfitting where we train the data too much according to the pattern of trained data rather than for all data or new data. Bias sampling in data collection can cause sampling bias. So when we give the bias samples, so the data can be uh, answer can be biased. Okay, thank you. That's all for section B. Let's meet for section B. Let's meet after section C. Oh, sorry. We will meet in section C explanation. Thank you.